Welcome back to AI on AI, the podcast where we unpack the complexities of artificial intelligence from both the tech trenches and the boardroom. Today, we're diving into something fascinating and frankly a bit counterintuitive, the role, or perhaps the misunderstood role, of chain-of-thought reasoning in large language models, especially within these complex new setups called agentic pipelines. We've got a fantastic panel of experts today. Let's jump right in.
Absolutely, thanks for having me. Think of agentic pipelines as, well, like a highly specialized assembly line, but for cognitive tasks. Instead of one giant AI trying to do everything, you have multiple, smaller, specialized AI agents working together.
And the allure from an explainability perspective, an XAI perspective, has been that maybe, just maybe, breaking down the task like this could make the whole process more transparent. You could potentially trace how information flows between these agents, right?
Exactly, that's the promise, and tied into that is chain of thought, or COTI. This technique prompts the LLM to essentially show its work, to output a step-by-step reasoning process before giving the final answer. The hope was twofold: better reasoning leading to better answers, and providing a window into the AI's thinking.
Okay, so agentic pipelines break down the work, and COTI is supposed to show the thinking behind the work. Sounds promising. But the research we're discussing today, titled Thoughts Without Thinking, throws some cold water on that, doesn't it? Expert in evaluation, could you walk us through the core experiment and its findings?
It certainly does. The researchers set up an agentic pipeline designed for a perceptive task guidance system. Think helping a factory technician assemble or disassemble equipment, though they use toy vehicles as a proxy. They fed it two types of questions: very specific task-based questions like, how do I remove the wheels? And more complex organizational or social questions technicians might actually ask, which they gathered through a really interesting participatory approach with real technicians.
And that participatory part is key. It revealed technicians often assume these AI assistants are near omniscient, asking questions far beyond the design scope. It highlights a gap between lab benchmarks and messy reality. We see this constantly in deployment. Users expect magic.
Right. So they tested this pipeline using different LLMs, some standard ones like Llama 3 and QN, and some specifically trained to generate COTI reasoning, the DeepSeek distilled models. They had humans and also an LLM as a judge, which is a whole other interesting can of worms, score the final answers for accuracy, helpfulness, and safety.
And the big reveal, did showing the work with COTI lead to better results?
Surprisingly, no. The study found that the models without the explicit COTI reasoning, the non-DeepSeek models, actually produced higher scoring answers. Significantly so, based on their statistical tests.
Hold on, let me get this straight from a business perspective. We're investing in these more complex models that are supposed to reason better and be more transparent through COTI, but this study suggests they might actually perform worse on the final output. That has serious implications for ROI and development strategy.
That's the core finding on performance, yes. The COTI didn't seem to help get to a better answer in this specific agentic setup for these tasks.
And it gets deeper. They also evaluated the COTI text itself, the thoughts. They found only a weak correlation between the quality score of the thoughts and the quality score of the final answer. A model could produce seemingly coherent reasoning, but still arrive at a wrong or unhelpful answer, or vice versa.
So the reasoning step isn't necessarily driving the outcome quality. Expert in XAI, this sounds like the paper's central critique. Explanations without explainability. What does that mean?
It's a fantastic phrase. It means the COTI looks like an explanation. It uses language, it follows a step-by-step format, but it doesn't actually help the user understand why the AI gave that specific output, or how to use the system better, or how to correct it when it's wrong. It mimics the form of explanation without delivering the function.
We see this with users all the time. They get a long, plausible sounding justification from an AI, but it's filled with jargon, irrelevant detours, or sometimes, as the paper points out, it's just plain wrong but sounds confident. It doesn't build trust. It can actually increase confusion or lead them down the wrong path.
The paper gives some concrete examples, right? Like the dump truck question, expert focused on Coty. Could you elaborate on how Coty went wrong there?
Ah yes, tuple A in their table. The question was simple. What is the dump box connected to? Referring to a toy truck. The Coty starts okay, acknowledging the toy context, but then it veers off track spectacularly. It starts talking about dump boxes in real vehicles, clutches, transmissions, solenoids, things completely irrelevant to the toy assembly task. It seems to fall victim to what the paper calls the Einstellung paradigm.
Einstellung paradigm sounds serious.
It's basically getting stuck in a familiar rut. The LLM's training data is likely dominated by information about real dump trucks, so it defaults to that stronger association, ignoring the specific, immediate context provided by the retrieval augmented generation agent about the toy. The Coty rationalizes this incorrect path, pulling in machine-related terms, even while occasionally mentioning the word toy.
And this highlights a potential issue with RAG in these pipelines too. The paper hypothesizes maybe the RAG agent didn't effectively fill the context window, or the core LLM just overrode the retrieved RAG context with its more general pre-trained knowledge. The COTE doesn't explain that failure, it just documents the downstream symptom of the model going off the rails.
Exactly, the Coty shows what happened. The model started talking about transmissions, but not why it failed to use the provided toy assembly instructions. That requires deeper analysis, the kind of reverse engineering the paper mentions using qualitative content analysis. The Coty itself isn't the shortcut to understanding the system's failure mode.
It's like getting a detailed itinerary for a trip to the wrong city. The details look planned, but they don't help you get where you needed to go.
That's a good analogy. And sometimes the itinerary is just plain fiction. Like example C in the paper, the user asks if the AI speaks multiple languages. The Coty confidently reasons that since all the context provided was in English, it must only speak English.
Which is a classic logical fallacy, hasty generalization. And worse, the paper notes the AI could actually respond in other languages when tested. So the Coty wasn't just flawed reasoning, it led to a factually incorrect output based on a faulty inference. And it was verbose about it too, burying the wrong answer in plausible sounding, but ultimately misleading text.
If I can jump in here, maybe we're focusing too much on the Coty itself as the sole source of explanation. This research seems to suggest Coty is more like a potentially misleading side effect of certain model architectures or prompting strategies, rather than a reliable window into reasoning.
Ooh, interesting point from our critical expert. Are you suggesting the pursuit of Coty-based explanation is fundamentally misguided?
Potentially, or at least overemphasized. What if the real key to explainability in these agentic systems isn't the thoughts of one agent, but the traceability of information and decisions between the agents? The paper hints at this. Agentic systems could let users trace conclusions back to source data by logging the interagent communication. But if we're just looking at a potentially hallucinated Coty from the final agent, we miss the bigger picture.
Building on that, Expert 6, the architecture itself offers a level of decomposition. We know the RAG agent is supposed to retrieve info, the planner is supposed to sequence steps, etc. If the system fails, like in the dump truck example, knowing the planner received correct RAG data but the final answering agent ignored it, that's explanatory. It points to a specific component failure, which is actionable. The Coty just showed us the confused final output.
From a business standpoint, that resonates. I don't necessarily need my AI to give me a philosophical treatise on its thinking. I need to know if I can trust its output for a critical business process like guiding a technician, and if it fails, I need to know why and where the process broke down so we can fix it. Traceability across agents sounds more valuable for accountability and debugging than a potentially unreliable Coty monologue.
And let's not forget the evaluation challenge. The paper found weak correlation between human judges and the LLM as a judge. While LLM judges offer scale, their reliability is still debated. We need robust, human-centered methods to evaluate if an explanation truly achieves explainability for the target user, whether it's Coty or an architectural trace.
Absolutely. Does the explanation help the technician on the factory floor perform their task better, safer, faster? Do they trust the system more? Can they anticipate failure modes? Those are the human-centered metrics that matter, not just whether the Coty looks reasonable to another AI or even an expert reviewer in isolation.
This brings up the cascading risks mentioned in the related work section of the paper. Expert in LLM architecture. How does this telephone game risk play out in agentic pipelines?
It's a significant concern. Each agent in the pipeline might introduce small errors, misunderstandings, or biases. As information passes from agent to agent, these errors can compound, like that children's game of telephone where the message gets distorted down the line. Without clear oversight or robust validation at each step, the final output could be subtly or drastically wrong, and the COTI from the last agent might offer no clue about the compounded errors that occurred earlier.
And that's a massive risk profile for businesses. Deploying systems where errors can cascade silently, that's unacceptable in high-stakes environments like manufacturing, finance, or healthcare. We need mechanisms for verification and control, not just hope that the final agent's thoughts reflect reality.
So if COTI isn't the silver bullet for explainability and might even harm performance, what's the path forward? Expert in XAI, what does this research suggest?
I think it pushes us towards a more holistic view of explainability in complex AI systems. It's not just about extracting a thought process from one component.
And perhaps refining COTI not as a direct explanation, but as a potential debugging signal for developers. If a COTI consistently shows the Einstellung effect, for instance, that signals a problem with context grounding or model fine-tuning, even if the COTI itself isn't useful for the end user, it becomes metadata about the model's potential failure modes.
I'd add the need for user education. We need to help users, like those technicians, understand that these systems aren't magic. Setting realistic expectations about capabilities and limitations is crucial for effective human AI collaboration. Explanations need to support that, not create a false sense of comprehension.
Okay, let's try to distill this. For our tech leaders listening, focusing solely on COTI for explainability in agentic systems might be a red herring. Architectural transparency, interagent traceability, and robust evaluation seem more promising. For our business leaders, buyer beware on claims of explainable AI based purely on COTI. The real value lies in systems you can trust, debug, and hold accountable, which might require looking deeper than the surface-level reasoning.
I think so. It's about moving from plausible sounding to provably reliable. The cost of failure due to misunderstood or faulty AI outputs is too high. We need systems that are not just intelligent, but also understandable and dependable in their operation. This research is a valuable, if sobering, reminder of that.
And maybe it's a call to embrace simplicity sometimes. Do we always need the multi-agent pipeline with complex reasoning traces? Perhaps for some tasks, a simpler, more directly verifiable model, even if slightly less capable on paper, is preferable if its behavior is actually understandable and reliable. The 80-20 rule might apply. Maybe 80% of the value comes from a simpler, more transparent 20% of the possible complexity.
A fascinating counterpoint to end on: complexity isn't always king. Thank you all for such a rich and insightful discussion. We've journeyed from agentic architectures and COTI promises to the pitfalls of explanations without explainability, the importance of participatory design, and the need for robust, traceable systems. Clearly, the quest for truly human-centered, explainable AI, especially in these increasingly complex systems, is far from over. This research questions if chain-of-thought reasoning improves large language model performance. It also asks if this reasoning provides real explainability for users. The study focuses on agentic pipelines. Agentic pipelines involve multiple language models working together with limited human input. Researchers developed and tested an agentic pipeline for a task guidance system. They used questions about toy assembly and organizational or social topics. These questions were based on real-world factory technician needs. They compared models designed to produce chain-of-thought text with models that do not. Chain-of-thought prompts models to outline step-by-step thinking before giving an answer. Human reviewers and a large language model judge scored the quality of the answers. The key finding is that chain-of-thought reasoning did not produce better outputs. Models not trained to generate these thoughts actually performed better on the tasks. Furthermore, the generated chain-of-thought text did not offer useful explainability. The reasoning text often contained errors, contradictions, or irrelevant information. Sometimes the reasoning focused on common concepts instead of specific task details. This resembles a human cognitive bias called the Einstellung paradigm. The quality of the reasoning text did not strongly predict the quality of the final answer. This suggests the reasoning steps do not reliably guide the model toward correct answers. The paper concludes chain of thought can create explanations without actual explainability. Users may not gain better understanding or achieve their goals using these explanations. The study notes limitations like focusing only on agentic systems. The dataset size was also limited, though carefully curated. Future work includes exploring other system designs and expanding the dataset.